That's why I always take 2 drones with me. We don't get the connection by now, and so I tried to build this using best practices, I think. Then I'll start with the presentation itself. So I'm sorry.
Are you going to change
No.
That's great.
This is
Competition.
I think it's this computer and it's not the drone itself. Did you change the drone?
No.
Okay. Maybe it's just... Let's try. Okay. Sorry for the interruption, but maybe it works now. It has worked before, so yeah, we got some battery indicators, and I got a picture. So this is great. So now I put this away again and put this on. Okay. So now I'm going to show you what steering the drone is like. To start, I'll put my hands up here. It doesn't have to be too close to the camera, it doesn't have to be too far away, but this distance is ideal, so I have some space to move my hands up and down, left and right. And when I want to start, I do a thumbs up gesture. When I did this, I can use my hands as like a steering wheel, or moving to the left and to the right. I can also move backwards and forwards by putting my hands forward and backward. And I can go up by putting my hands up, down again by putting. So if I want to do some more, I can move my hands in the opposite direction, and this does the trick. Yeah. And of course you always have to do a 360-degree turnaround, because everything else would be so confusing. Okay, so these are the basic steering concepts. If I want to land, I do a thumbs down gesture again. And this is all done using the Perceptual computing SDK. Okay, so let's get to the talk. So, this was the challenge itself, so our demo. And what we were building is called the Parroteer project. It's basically its basic concepts are the AR drone itself. So we can steer a normal off-the-shelf product using the SDK. The drone itself costs about 300 euros. It's available everywhere in normal places where you would get electronics, so Saturn or MediaMarkt is a fine place to get it. How do we connect to the drone? We have to do some socket magic, so we have to connect to some UDP, some TCP sockets, get some binary stuff out of there, interpret it the way we want, and then we can use the data we get. So this is pretty low level, and what we basically did to get around the low level stuff and get to the language where we wanted to was to implement a wrapper. So Basically, when you're using this wrapper, which is open source, you can also download it. You can just say take off to the drone, or you can get enough data out of it by using a listener or a picture listener or anything else. So everything you want, you get it with the normal Java way, you would say. Okay, this is the normal control you would normally use with the drone. So you can use it, use your smartphone. You can steer by putting it this way and that way. You can move to the back and to the front by putting it down and moving it up, and you can do the other directions also. This is really this was cool 2 years ago, I think, but today we got way cooler implementations. So our idea for the perceptual computing hack night was to implement it using the perceptual computing SDK. Okay. The features of our presentation is, of course, that it's hands-free, so we don't have to do anything using a mouse, using the keyboard, or using a touch screen or something like that. Everything can be done with your hands, and you don't have to put them anywhere. So we also implemented the complete turnaround, so every direction can be controlled, every direction that this drone can access can be controlled. So the yaw is possible, back, right, forward, and so on and so on and so on. We used the gesture recognition that was provided by the Perceptual Computing SDK. So basically these gestures are standard gestures you can easily access using just the standard SDK. And we, of course, we also used all the stuff we would get out of the SDK itself. So basically the point where the hand is at the moment, we can get it out. But we'll see a little bit later as we get into the code. As you maybe saw, we got a reference point here. So when we start the drone, everything is calculated from that reference point. So we start at this point and we move our hand forward from this point, and the drone flies forward. If we move it back this way, it goes backward. And the same is done using the height. So this is something you'll have to know, because if you move away from the drone and move back in, maybe the drone flies a little bit backward because it's still got a reference point. The reference point is only deleted when you land. Okay, and what we basically needed was some smoothing, because it is really difficult. It was difficult back then with the Perceptual Computing SDK version 2 to get precise values. So we got differences in the values that weren't acceptable. So the drone was flying around. It was a little bit quirky, and this wasn't the way we wanted to do it. So after the challenge, we implemented some filtering. We tried out different filters. So we did some Kalman filtering. We tried some bilateral filtering, which we basically use now, and also simpler stuff. But with the Kalman filter, it's really a good way to steer the drone, because it's reactive and still it gets smoothed pretty well. Okay, which tools did we use? Basically, this is the standard tool stack I would like to use every time. So we used Java as a programming language. We use the native bindings of the Perceptual Computing SDK, so you can just compile them from the standard SDK if you download it using the make file, and then you got a native library, a DLL, and you can embed it into your application. As a version control system, we use Git, as we always do by now. Maven as a build system. You can see we didn't use Gradle for this one, but this is just a convention because we're much more used to Maven than we are to Gradle. But this will, I think, this will change it within the new, next few years. Oops, I forgot. We implemented it so that we can use it using Eclipse as well as IntelliJ. The only thing we need is JavaFX support, which I think it comes natively with NetBeans, so we can also use NetBeans for that. Okay, let's talk a little bit about the architecture. We try to implement some best practices that we're used to at work because we really think that these practices are important. So clean code is very important to us. So basically we're using meaningful names. We're trying to keep classes no longer than, let's say, 150 lines of code. Methods no longer than 10, 15, maybe a little bit less, but around that way. And we also try to do some separation of concepts. So on the top level you see these 5 modules. We have the internal control, which is basically just the view, which is the JavaFX window. You can see when you look at this screen. We also got it for the leap motion. They are a little bit different, so we implemented 2 versions of it. And on the bottom side, we've got the Perceptual library, which basically means that we created a wrapper for this library because everything in there is a little bit C-style, and we don't want to do it C-style. So we implemented some listeners, we implemented the usual stuff you would like, and you also get a picture and an integer array, and this is really better than the standard version, I think. Then there's the drone API, which is basically there for steering the drone itself, so this is the wrapper I already talked about. And the leap perceptual, this is for the leap motion version again, the same thing we would use for the perceptual SDK version, but this time for the other camera. Yeah, and everywhere you get, you'll see that we got some more abstraction layers and trying to build stuff that is really reliable. So we also use dependency injection for this. This was done using the Juice framework, so basically the same stuff here as we saw in the Android talk. We could also implement some other dependency injection here, but this is by far the most lightweight one, I think. And the standard implementation of the JSR 330, so we like to use it whenever we can. Yeah, and we try to also keep the complexity at a low level, so there's not the cyclomatic complexity of the code is pretty low, I think. Okay, and also there's some things we built in that we wanted to have there. These are not the architectural patterns, but patterns we would like to see in perceptual computing more and more. So there's the hover mode. Whenever we step out of the picture and our hands were like this when we stepped out, the drone goes into hover mode. It doesn't just fly this direction until it crashes against the next wall. This was a really hard way, so the first time it did exactly this, so this was hard to learn. What we also implemented was the coordinates moving, so the user gets a better experience out of his flight experience. And with version 2 we got a lot of false positive regarding gesture detection, so there was, let's say, 3 real values, then there were 15,000 fake values, and then there were 3 real values again. So gesture reassurance was a real problem back then, but by now it's really, really robust. So version 3 brought a lot of nice stuff with it. Okay, so these were the basic concepts of our presentation. What I'd like to show you now is some code, and I'll get right to it. I'm also using IntelliJ, so basically Android Studio was a real cool thing for me. Is it good enough? Can you read it?
I think there's a presentation mode in IntelliJ, or at least in Android Studio. I think it's in the View menu.
View?
Maybe it's only in Android Studio.
Enter full screen maybe in View, and then down.
Yeah, this is a lot better now.
Decrease the resolution.
What do you mean?
Decrease the resolution of the monitor.
Yeah, we can do this. But I think, is it really that difficult to read it by now? Yeah, it's okay. So I don't want to waste any more time. Okay, so the most important project for the Perceptual Computing SDK is the Intel Perceptual package. So it's a multi-module project here. Intel Perceptual is all about getting the coordinates out of the SDK for the main part. So we got the Perceptual part here, and first of all, there's the Perceptual controller, which you will use if you want to get anything out of it. And as you can see, there's a picture component, a detection component, and a gesture component. These components are there for getting the things I want to get out of them. So within the package component, we got, for example, which one is the easiest one? I think the detection component is the easiest one. We got this one, and here what we are basically implementing is the query features and the process features. Query features just means that you have to ask the SDK what you want. So in this case, I want the query geonode method. So I want a geonode object which I'll pass to it, and the SDK will fill it for me after when we get to the process features section of the part. And when we got there, we get using the methods get smooth coordinate and get coordinate, we get the coordinates out of the geonode itself. And this is basically it. Everything else is just filtering and everything you don't want to do yourself, basically. And if we want to get events out of it, we just have to add a listener to this component, which is delegated by the perceptual controller. So every time we add the gesture listener, we get this one. We get a gesture. What is the event called? A gesture data event or something like that out of it whenever the SDK detects a head. Okay, the same thing applies for the gesture and the picture. And let's see what the CAM processor, the main object, does. It's mainly, it just queries frames. It's just a thread that runs on your machine and queries frames. And what it does is it acquires a frame at first. This is the perceptual computing stuff you have to do if you do it for yourself. Then I go through all the components I got and query their features. Then I call a release frame, and after the release frame all the geonodes are filled, all the data I want to have is mixed up with the values I want to get, and after that I can call process features, which then can call the listener, can invoke the listeners which are registered at the objects. Yeah, and this is the main stuff. So if you see, here we got some filtering. So I implemented a lot of filters and tried to get out the best of them. So the best one was the bilateral filter, because it lets you, it recognizes hard edges, and these hard edges are then not filtered, whereas relatively noisy edges are filtered out. So if we got small steps and then there's a big change in the data, the big change is not filtered out, whereas the small changes are smoothed. This is a really cool filter. Okay, and if we want to use it, finally we go into the Intel control module, and there we have the drone input controller, and this drone input controller gets all the stuff we need. So it has a on gesture method, which it implements using the gesture listener. There's a coordinate listener and all the listeners you need, and then it directly it reacts to the things we have here and starts the drone if we have a thumbs up gesture. And the drone input controller is there for combining all the stuff. Okay, so that's the basic architecture of the drone. If you want to fly for yourself, I think there's time after the pizza. And
during the pizza.
And during the pizza, so you can eat while so you don't have to touch a keyboard while flying.
I have just one question.
Yeah.
Actually, first you said it's hands.